So, how do we decide how many clusters we want? Well, in that previous case, I chose 4 because I knew something about the data set, but often that's not the case. And often we can't even visualize the data. There's too many dimensions to visualize it. So we have a couple of techniques that we can use for choosing k. In fact, there's a number of techniques, but we're going to look at 2 of them. Usually, these techniques, you give them several values of k, a range of values of k. You choose that range, and then it will evaluate. It will do a clustering for each of those values of k. So, 2 mean cluster, 3 means cluster, 4 means clustering, and then see which one is the best. So there's 2 ways of doing this. One is the elbow method, which has a measure called the within cluster sum of squares, which is something to do with how coherent the cluster is, how well contained it is, and that can then be plotted. You can take the values. So for different values of k, this is the values of k on the bottom here. We can plot the within cluster sum of squares and look for a point where that changes. So what you're looking for is the elbow, where this line has a bend in it, if you like. The technical way of doing that is to look at the smallest angle between the 2 lines coming into the point. So if you think about this point here, the 2 lines coming in are pretty much at 180 degrees from each other. So that's the biggest angle you'd get. Whereas here, there may be the angle between this line and this line is maybe, I don't know, 145 degrees, something like that, 150. So that's the smallest angle, smaller than all the others, which are around about 180. And so that's the one we pick as our elbow point, which is telling us that k, in this case, for that particular data set, a good value for k is 4, according to the elbow method. The other method is the silhouette method, and that calculates the average silhouette score for each k. You can look up the Wikipedia page to find out more about that, and then it finds the maximum. Okay, so let's try that out. So in this next example, we're going to try and find those values. So this code allows us to do that. We have to pick the range of values that it's going to evaluate. So I want to go from k is 2 to k is 10. Obviously, there's no point doing k is 1 because that's just one cluster, and that would just have all the data in it. There's no sense of a clustering then, because all the data would go in the first cluster. So start with k is 2 or something higher. K is 10 seems like a reasonable number to go for when we've only got 25 rows in this, 25 data points in this data set, because we're looking at the summary data. You could go higher. The only restriction on how high you go is the higher the value, the longer it'll take to do its calculations. So you don't want to pick that too high. Okay, and then you loop over this then generates some values of k from the minimum to the maximum one. It creates these 2 lists, WCSS and silhouette, and then it loops over those k values, all the k values, which in this case are going to be 2, 3, 4, 5, 6, 7, 8, 9, and 10. And each time around the loop, it does a k-means clustering, and then it finds that clustering from the labels, and then it can calculate or it can get the WCSS value, the within cluster sum of squares, from k-means.inertia. So that's a field inside the k-means object. Or it can get the silhouette score from a method called silhouette score, which needs the labels to do the calculation. Okay, and then they get added to the list. So we've got a list of each time around the loop. This list gets one value added to it, which represents the quality of that clustering. And finally, just so I can visualize these together on the same chart, I'm going to normalize the WCSS values so that they lie between 0 and 1. So that's already true of the silhouette values, silhouette scores. So that means I can put them both on the same chart. So to plot the chart, I just need 2 line plots, basically. So I create one figure with 2 line plots. First one does the WCSS values, the next one does the silhouette scores, and that's going to look something like that in this case. Okay, you can see the blue one is the within cluster sum of squares, so that's the elbow method, and the orange one is the silhouette score. there's no really pronounced elbow for the WCSS. I guess you'd say the elbow's possibly here, which is corresponds to K being 3, but it's not very pronounced. For the silhouette, the maximum value is definitely at 2. It's much higher than any of the other values. But you can also see, excuse me, there's a local maximum at K is 7. Local in the sense that it's bigger than its nearest neighbours. So all the other values, 6, 5, 4, 3, 8, 9, 10, are all smaller. The silhouette score for all those values is smaller, so we call that a local maximum. So it's worth considering both of those points. I'm going to forget about the elbow method for this one because it's not very conclusive. So in order to do the clustering then, we just run the example 1 again, but with now K is 2 and K is 7. Okay, you could pick K is 3 from the elbow method as well if you wanted. So that's what happens when you do K is 2, and you can see immediately for K is 2, it's picked out the high volume products here and everything else in this cluster. So that doesn't tell us very much that we didn't already know. For the K is 7, that is perhaps a bit more interesting because it's actually managed to pick out high, medium, low, and very low products. So the high are these 2 clusters, the medium is this cluster, the low is these 2 clusters, and the very low are these 2 clusters. So it's picked out those as 4 separate groups of clusters. But you can also see it's then divided those clusters up, what we had already decided as segments, so that was the high volume segment. It's divided that into 2 pieces. The medium volumes have stayed in the same cluster, but the other clusters have all been split into, or other segments have all been split into 2 clusters. One side of the segment is high marketing values, so anything above about 20,000. There's the line marketing 20,000. All of those go in their own cluster, and then all of these clusters are low value marketing. So it splits it. It seems to be splitting it both by segmenting it by sales, as we'd already done manually, but it's also segmenting it by high and low marketing, which is what you'd expect, right? It's only been given the sales and the marketing values to deal with, so you'd expect it to do some sort of clustering based on those values. So the interpretation then is because we're doing this in 2 dimensions, the marketing and sales, we can easily identify those clusters visually, and those are the data points which are closest together in 2 dimensions. And for K is 2, it just separates out the high volume sales from everything else. For K at 7, it's got the 4 different sales volumes, so high, medium, low, and very low. But as I said, it's additionally split 3 of those segments into 2 groups each, where you've got the left-hand side is the low marketing values and the right-hand side is the high marketing values. Okay, so that one's quite easy to interpret. Let's have a look at another data set. This is actually a data set we haven't seen yet, which is a little bit harder to interpret. Okay, so I'll stop that video there and then we'll look at another data set.